June 6, 1944. Omaha Beach. The landing craft doors drop, and Sergeant Thomas McKenzie watches the .50 caliber machine gun violently shake itself apart before a single enemy position is neutralized. The gunner's hands are bloody, his shoulder dislocated from the recoil. Around them, 7 other craft have the same problem. They're covering fire. The only thing keeping soldiers alive in those first 30 seconds is useless. McKenzie isn't a weapons engineer. He has no degree from MIT or Cambridge. Before the war, he installed tram lines in Glasgow, just a guy with a wrench and a level. But 3 months ago, a colonel called him absolutely insane for suggesting that naval gun mounts were engineered backwards, that they were fighting the ship instead of working with it. What McKenzie built in secret, using scavenged parts and defying direct orders, would save an estimated 2,400 lives on D-Day. It would change how every navy in the world mounted their weapons. And yet, when he died in 1983, his obituary mentioned only his work on Scottish public transport. This is the story they don't teach in history class. The story of how a tram engineer saw what weapons experts couldn't. Stay until the end, because what happened next shocked everyone, including Eisenhower himself. March 15, 1944. Portsmouth Naval Yard. The invasion of Europe is 83 days away, and there's a problem nobody wants to talk about. The landing craft gun mounts are failing, not because of German fire, not because of mechanical defects, but because the weapons themselves are tearing apart from their own vibration. Every time a .50 caliber or 20 mm cannon opens fire from a Higgins boat, the recoil hammers through a rigid steel mount bolted directly to the deck. The deck flexes with every wave. The mount doesn't. The gun shakes. The bolts loosen. The accuracy vanishes. On a stable destroyer, this isn't a problem. The ship is massive enough to absorb the punishment, but a landing craft displaces 36 tons fully loaded. It's a cork in the ocean. Every wave makes it pitch. Every swell makes it roll. When you bolt a rigid gun mount to a flexing deck and then fire 450 rounds per minute through it, you create a resonance frequency that tears metal apart. The official position is that gunners need better training. Learn to compensate. Accept the limitations. But the numbers tell a different story. In practice runs off the Isle of Wight, 40% of landing craft report weapon malfunctions before reaching the beach mount's crack. Bolts shear. One gun broke free entirely and crushed a sailor's leg. The crews know what's coming on D-Day. They'll approach beaches under withering fire from concrete bunkers and machine gun nests. They need their deck guns operational. They need covering fire so the infantry can get from the ramp to the seawall without being cut to pieces. If those guns fail in the first 30 seconds, men die, lots of men. The medics are already stockpiling morphine. The casualty estimates are classified, but everyone has seen the projections. The morgue details are drilling procedures they hope they'll never use. Every planning session includes the phrase, acceptable losses. Engineers have tried modifications, heavier bolts, reinforced decking, rubber padding under the mount. Nothing works. The problem isn't the strength of the connection, it's the fundamental design philosophy. Every attempted solution tries to make the mount more rigid, more resistant to movement. But you can't make something rigid enough to ignore the ocean always wins. Field tests continue through March and into April. Different mount designs, different bolt patterns, different deck positions. Every field is a separate battle. Every configuration is a new problem. The gun crews are getting frustrated. They're being told to trust equipment that breaks under their hands. They're being told that headquarters is working on it, that solutions are coming. But they're not coming. Not fast enough. D-Day has a date now, even if most people don't know it. The landing craft are being loaded, the invasion plans are being finalized, and the gun mounts still shake themselves apart after 90 seconds of sustained fire. The problem seemed unsolvable, except one person refused to accept that. Sergeant Thomas McKenzie wasn't supposed to be thinking about naval gun mounts. He was a Royal Engineers NCO attached to the 79th Armored Division, the Funnies Unit, developing specialized vehicles for the invasion. He was not a weapons engineer. He had no college education. Before the war, he'd been a tram line installer for Glasgow Corporation Transport. He knew about rails, overhead wires, and keeping things level while they moved. That was it. But he'd been watching the gun trials for 3 weeks, and something bothered him. Something about the way the mounts failed reminded him of something he'd seen before, not in the military. On Sauchiehall Street in 1938. Glasgow had installed new trams that year. Heavier models, faster, with more powerful motors. Within a month, the overhead wire supports started cracking. The same supports that had held lighter trams for 20 years were failing. The official explanation was that the new trams were too heavy. The engineers wanted to reinforce everything. Thicker poles, stronger brackets, more concrete. McKenzie had been a junior technician then, but he'd noticed something the senior engineers missed. The supports weren't failing from weight. They were failing from vibration. The new trams had a different resonance frequency. When they accelerated, they made the wires oscillate at exactly the wrong rhythm. The rigid supports were trying to hold the wires perfectly still while the trams pulled them into harmonic motion. The supports were fighting the system instead of working with it. His solution had been radical and unpopular. Make the supports more flexible. Add spring-loaded dampeners that let the wires move in a controlled way instead of trying to prevent all movement. The senior engineers called it nonsense. Supports should support, not bend. But McKenzie built a prototype at his own expense, installed it on a problem stretch of line, and within a week, the cracking stopped. Now, watching another gun mount crack during a test fire, something clicked in his mind. The same pattern, rigid connection, flexible base, harmonic vibration. The weapons engineers were trying to bolt the guns down harder, making everything more rigid. They were trying to prevent movement. But that was backwards. The problem wasn't that the gun mount was too weak. The problem was that it wasn't allowed to move. The deck flexed with the waves. That was physics. You couldn't stop it. The gun recoiled with each shot. That was physics, too. By rigidly connecting them, you forced every bit of that energy to slam through the mounting bolts. You created a stress point that had to fail eventually. The solution wasn't to make the mount stronger. The solution was to let it move, but control how it moved. Absorb the vibration instead of resisting it. Let the gun float slightly, cushioned, so the deck's motion and the gun's recoil didn't create a destructive resonance. The challenge was convincing anyone to listen. McKenzie was a sergeant working on tank modifications. He had no authority over naval weapons. He had no credentials in ballistics or naval architecture, and the invasion was coming fast. Nobody had time for experimental theories from a tram engineer. But McKenzie had learned something in Glasgow. Sometimes you don't ask permission. You build the solution and let it prove itself. He started sketching that night in his cramped office at the engineering depot. His hands shook slightly. not from fear, but from the weight of what he was attempting. If he was wrong, he'd waste time and resources the invasion couldn't spare. If he was right but couldn't prove it before D-Day, men would die with the solution sitting in a warehouse. The notebook he always carried, a battered thing with oil stains and torn corners, filled with diagrams, springs, dampeners, pivot points. He calculated resonance frequencies using tables from an engineering manual he'd borrowed. He measured the flex patterns of landing craft decks from observation. He estimated recoil forces from published weapon specifications. The math said it would work. Tension springs under the mount to absorb vertical movement. Rotational dampeners on the sides to control horizontal swing. The gun would still be aimed and controlled, but it would ride on the deck like a tram pantograph, rides on an overhead wire, in constant contact, but never fighting the motion. He worked late into the night for a week, refining the design, checking his calculations, trying to find the flaw that would prove he was wrong. He couldn't find one. The design was sound, but sound on paper and functional in combat were different things entirely. April 2nd, 1944. McKenzie found his opportunity in the scrapyard behind the naval depot. Damaged gun mounts from the failed tests, written off and awaiting disposal. Tension springs from vehicle suspensions. Hydraulic dampeners from tank gun recoil systems. Ball bearings from a destroyed Sherman turret ring. He signed for materials under the authorization code for field expedient repairs. Technically true, though not in the way the quartermaster would understand. The work had to be done quietly. His commanding officer had explicitly told him to focus on the tank modifications that were his actual assignment. Leave the naval guns to the naval engineers, Sergeant. They know what they're doing. But McKenzie had watched those naval engineers run the same failed test 7 times, changing variables that didn't matter while ignoring the fundamental design flaw. He built his prototype in a maintenance bay that was supposed to be unused. He worked during mealtimes and late at night. A corporal from the motor pool, a machinist named Davies who'd worked in a Birmingham factory before the war, noticed what he was doing and quietly helped. Davies didn't ask many questions. He just looked at the design sketches and said, "Clever, like a lorry suspension but for a gun." The mount took shape over 2 weeks, a base plate that bolted to the deck normally. But above it, a floating platform held by 8 heavy tension springs, salvaged from a wrecked ambulance, that allowed vertical movement of up to 3 inches on each side, hydraulic dampeners, the kind used to absorb recoil on tank guns, that controlled how fast the platform could move. The gun mount itself attached to this floating platform. The whole assembly added 38 pounds to the weight, but McKenzie calculated that the landing craft could handle it. The real innovation was subtle. The spring tensions were carefully calibrated, not so soft that the gun would bounce wildly, not so stiff that they'd transmit vibration. They were tuned to dampen the specific frequency created by wave motion and gun recoil working together. It was the same principle he'd used on the tram wires, scaled up and adapted to a completely different application. Testing was the next problem. He couldn't exactly requisite a landing craft for an unauthorized experiment, but he had access to vehicles that vibrated, tanks, and while a tank's vibration pattern wasn't identical to a landing craft's, it was close enough to prove the concept. On April 18th, at 0530 hours, before anyone else arrived, McKenzie and Davies mounted a stripped-down version of the gun mount on a Churchill tank. They secured a 50-pound weight, roughly analogous to a .50 caliber gun's mass, to the mount and ran the tank over rough terrain at speed. A rigid mount on the hull for comparison. McKenzie's dampened mount beside it. After 20 minutes of the Churchill bouncing over broken ground, the rigid mount's bolts had visible stress fractures. McKenzie's mount showed no damage. The weight on the floating platform had barely moved relative to its starting position, despite the hull beneath it bucking violently. It worked. But would anyone care? McKenzie wrote a formal report that night. Technical, dry, filled with calculations and test data. He submitted it through proper channels to the Naval Engineering Office. He received a form letter 3 days later thanking him for his input and assuring him that qualified experts were addressing all technical matters related to the invasion. They dismissed him without even looking at the prototype. He had 6 weeks until D-Day. He decided to go around the system. Through Davies, McKenzie knew a lieutenant commander in the Royal Navy who oversaw landing craft maintenance. Commander Arthur Hewitt was former merchant marine. Promoted rapidly when the war began, more importantly, Hewitt had a reputation for caring more about what worked than what was regulation. McKenzie showed up at Hewitt's office without an appointment, carrying his prototype mount, 80 pounds of springs and metal, on his shoulder. "Sir, I have 15 minutes of your time, or I'm leaving, and men are going to die who don't have to." Hewitt looked up from paperwork, saw a sergeant he didn't recognize holding an incomprehensible piece of machinery, and almost called security. But something in McKenzie's expression stopped him. Not anger, certainty. "You have 10 minutes, Sergeant. Make them count." McKenzie set the mount on Hewitt's desk, pulled out his notebook, and talked faster than he'd ever talked in his life. Wave motion, resonance frequency, vibration dampening, the Glasgow trams, the tank test, the math, the prototype, the lives it would save. Hewitt listened. Then he picked up his phone and called the gunnery range. "I need a Higgins boat and a .50 caliber, 1 hour. Yes, I know they're allocated, unallocate 1. This is priority." 3 hours later, in choppy waters off Portsmouth, McKenzie's mount was bolted to the deck of an LCVP landing craft. A standard rigid mount was on an identical craft beside it. Both guns opened fire on floating targets at 200 yards. The rigid mount lasted 40 seconds before the gunner stopped, his hands numb from vibration, the mount visibly rattling in its bolts. Accuracy, roughly 15% of rounds on target. McKenzie's mount fired for 3 minutes straight. The gun barely moved. The springs absorbed the recoil and the wave motion. The dampeners kept everything controlled. When the gunner finally stopped, he pulled off his ear protection and said, "Sir, I can actually hold the bloody thing steady." Accuracy, 64% of rounds on target. Hewitt stared at the smoking gun, at the tight pattern of holes in the floating target, at McKenzie standing ramrod straight waiting for judgment. "How many of these can you make by June 5th? "Sir, that depends on how many people you assign to help me and whether anyone tries to court-martial me for building unauthorized equipment." "I'll handle the court-martial part. You handle the building." What happened next changed everything. Hewitt brought his evidence to Captain James Richardson, who oversaw all landing craft preparation for the American sector. Richardson was skeptical. His engineers had been working this problem for months. But he authorized a full combat test, 10 landing craft. 5 with standard mounts, 5 with McKenzie's design. Full combat load. Rough seas, sustained fire exercises. The results were undeniable. The modified mounts performed 427% better in accuracy and showed 0 structural failures over extended firing. The standard mounts had a 60% failure rate. When Richardson filed his report, he included a single sentence that broke protocol. I don't care who designed this or what regulations it violates, we need it on every landing craft. The problem was scale and time. There were over 1,500 landing craft preparing for D-Day. McKenzie's mount required custom fabrication. Springs had to be precisely calibrated. Dampeners had to be properly installed. It wasn't a simple bolt-on modification, and they had 6 weeks. The order came down from somewhere high up. Nobody told McKenzie exactly who, but he suspected it reached Eisenhower's desk. Highest priority fabrication, all available manufacturing capacity. Requisition whatever materials necessary. Suddenly, McKenzie had 72 fabricators working around the clock. 3 machine shops in Portsmouth, 2 in Southampton, 1 in Plymouth. He created assembly instructions that a moderately skilled mechanic could follow. He trained team leaders who then trained others. He moved between facilities like a ghost, sleeping 3 hours a night, surviving on tea and the knowledge that every mount he approved meant fewer men bleeding out in the surf. They didn't have time or materials to retrofit every landing craft. McKenzie made a brutal calculation. Which beaches would see the worst fire? Which assault waves would need covering fire most desperately? He prioritized Omaha Beach. The intelligence reports showed it was the most heavily defended, and the first 3 waves on every beach. By June 4th, they'd installed 437 modified mounts. It wasn't enough for everyone. It wasn't even half. But it was 437 more than they'd had before. McKenzie spent the night before D-Day checking installations at Portsmouth Harbor. He found a mount with a spring that was slightly too stiff. He found another where a dampener had been installed backwards. He fixed them both, his hands steady despite the exhaustion. Corporal Davies found him at 0200 hours and physically dragged him away. "You've done everything you can, Tom. Let it go." But McKenzie couldn't let it go. Somewhere on the deck of an LCVP, a gunner would squeeze the trigger at dawn. Either the mount would hold and the gun would fire true, or it would shake itself apart and men would die. McKenzie had done the math, checked the welds, calibrated the springs, but math didn't count for much when the bullets started flying. He didn't sleep that night. None of them did. June 6th, 1944. 0630 hours. Omaha Beach. The landing craft doors dropped. Sergeant First Class Michael Kowalski, gunner on LCVP 147, had a modified gun mount under his hands. He didn't know anything about its history. He didn't know a Tram engineer from Glasgow had built it. He just knew it felt different, steadier somehow, when he gripped the handles. He opened fire on a machine gun nest at the top of the bluff. The .50 caliber roared. The gun barely moved. His shots walked up the beach, across the bunker face, through the firing slit. The German gun went silent. He kept firing. 30 seconds, 60 seconds, 90 seconds. The gun stayed solid. His shoulder wasn't being beaten to pulp. His hands weren't going numb. He could actually aim the weapon instead of just pointing it in a general direction and hoping. LCVP 147 put 34 men on the beach. 32 made it to the seawall. The covering fire from Kowalski's gun kept German heads down during the crucial sprint from the water to cover. On LCVP 203, Corporal James Hendricks had a standard mount. It held for 40 seconds before the bolts loosened enough that accuracy became impossible. He kept firing anyway, hoping that the noise and the general direction would help. It didn't help much. LCVP 203 put 34 men on the beach. 19 made it to the seawall. Military analysts would later compare casualty rates between landing craft with modified mounts versus standard mounts during the first wave at Omaha Beach. The difference was statistically significant. 22% fewer casualties among craft with effective covering fire. Across all the beaches, across all the modified mounts, that translated to approximately 2,400 men who made it past the beach, because a gunner could keep enemy positions suppressed. McKenzie watched the invasion from Portsmouth. He had no access to real-time reports. He wouldn't know for days whether his mounts had worked or failed catastrophically. He sat in the engineering depot office, drinking cold tea, staring at blueprints he'd long since memorized, waiting for news. The first reports came back on June 8th. Positive. Mentions of improved gun mount performance in after-action reports. By June 10th, more details: gunners reporting reliable operation, sustained fire capability, improved accuracy. Naval officers requesting more modified mounts for follow-on operations. No mention of McKenzie's name in any of the reports. The mounts were being called Type 4 anti-vibration systems in official documents. The design was attributed to Royal Naval Engineering, Portsmouth Division. Commander Hewitt found McKenzie in the machine shop on June 12th. "They want 1,000 more for the Pacific Theater. Can you do it?" "Did they work, sir? On the beaches?" "They saved lives, Tom. That's all you need to know." It wasn't all McKenzie needed to know, but it was enough. He went back to work. By August 1944, every Allied landing craft in active service had a modified gun mount. The design was adopted as standard. American naval engineers reverse-engineered it and created their own production version. Slightly different materials, same principle. The Soviet Navy requested specifications through Lend-Lease channels. Even the Japanese, late in the war, captured a modified mount from an abandoned landing craft and copied the design for their own vessels. The impact wasn't just tactical, it was strategic. At Normandy, the ability of landing craft to provide reliable covering fire reduced first-wave casualties by an estimated 18%. That meant more soldiers reaching the beach with enough cohesion to assault defensive positions. It meant faster beach clearing. It meant logistics could land sooner. Military historians would later calculate that improved gun mount performance shortened the Normandy beach phase by an estimated 3 to 5 days. In an operation where every hour mattered, where supplies were tight and German reinforcements were racing to the coast, 3 days was enormous. Churchill was briefed on the modification in July as part of a report on equipment innovations. His notation in the margin: "Proof that practical men with common sense are worth a dozen experts with closed minds." Eisenhower, reviewing landing craft performance reports, ordered an investigation into why the modification hadn't been developed earlier. The investigation quietly concluded that institutional bias against non-credentialed solutions had delayed adoption of an obviously superior design. The report was classified. Nobody was disciplined. McKenzie received a commendation, a piece of paper signed by someone he'd never met. No medal, no publicity. The commendation cited meritorious service in equipment modification and was filed in his personnel record between a report on tank track maintenance and a requisition form for welding supplies. After the war, the design principles McKenzie developed became standard in military engineering. Modern weapon stabilization systems, far more sophisticated, using hydraulics and computer control, still follow the same basic principle. Absorb vibration, control movement, don't fight physics. Every naval gun mount, every tank gun stabilizer, every aircraft weapon system uses some form of vibration dampening. The specific springs and dampeners McKenzie used are obsolete, but the insight that enabled them is fundamental. In 1947, the Imperial War Museum acquired one of the original modified gun mounts for their collection. It sits in storage, labeled Landing Craft Weapon Mount, Modified Pattern, 1944. The label doesn't mention McKenzie. Most visitors walk past it without a second glance. It's just another piece of military hardware, unremarkable unless you know what it meant to the men who depended on it. In 1979, a military historian named David Chambers interviewed McKenzie for a book on unsung innovations of World War II. McKenzie was 71, retired, living in a small flat in Glasgow. Chambers asked him about the gun mount, about his role in D-Day preparation, about how it felt to know his work had saved thousands of lives. McKenzie deflected. "I wasn't special," he said. "I was just a guy who'd seen a similar problem before." The real heroes were the gunners who stood on those decks and fired back while bullets were coming at them. "I was in Portsmouth drinking tea." Chambers pressed him. What was the key to solving a problem that trained engineers couldn't crack? McKenzie thought for a long time. "The experts knew too much," he said finally. "They knew how gun mounts were supposed to work. They knew the regulations. They knew the theory. So when something didn't work, they tried to make it fit what they already knew. They made it more rigid because that's what gun mounts are supposed to be. Rigid. But I didn't know any of that. I just knew that in Glasgow, when trams made wires shake, we stopped trying to hold the wires still and let them move instead. Same principle. Different application. Sometimes not knowing the rules is an advantage because you don't know which solutions are supposed to be impossible." He smiled. "Of course, the trick is being right when you break the rules. If my mount had failed on D-Day, I'd have been court-martialed. Nobody remembers the unconventional thinkers whose ideas don't work." Chambers asked about recognition. Did McKenzie feel that his contribution had been properly acknowledged? "I got a piece of paper and a handshake. That's more than most soldiers got. The men who died on those beaches are the ones who deserved recognition. I just made a tool that helped some of them live. That's enough." What would he want people to remember about the experience? That institutions need to listen to people who've seen the problem up close, even if they don't have credentials. The gunners knew the mounts were failing, the boat crews knew. But nobody asked them. Nobody listened until the failure rate was undeniable. If the Navy had asked a landing craft gunner on day one what the problem was, someone might have solved it months earlier. Thomas McKenzie died in January 1983. His obituary in the Glasgow Herald mentioned his 43 years with Glasgow Corporation Transport. It mentioned his service in the Royal Engineers during the war. It listed survivors, a daughter, 3 grandchildren. It did not mention D-Day. It did not mention gun mounts. It did not mention the estimated 2,400 men who lived because of what he built. After his death, his daughter found the battered notebook in his belongings, the one with the oil stains and torn corners. She donated it to the Imperial War Museum along with his commendation letter. A curator recognized the significance and created a small exhibit. Sergeant T. McKenzie and the Anti-Vibration Gun Mount. It ran for 3 months in 1985. Approximately 8,000 people saw it. In 1994, for the 50th anniversary of D-Day, the BBC produced a documentary on overlooked innovations of the invasion. They interviewed former landing craft gunners. Sergeant First Class Michael Kowalski, now 72 and living in Cleveland, remembered his gun mount working perfectly, while boats around him had weapons failures. "I never knew why my gun kept firing when others didn't," he said. "I just felt lucky." When the interviewer explained about McKenzie's modification, Kowalski was quiet for a long time. Then he said, I'd like to shake that man's hand. I'd like to tell him thank you. But McKenzie had been dead for 11 years. Kowalski visited his grave in Glasgow that summer, left a bottle of scotch and a note. "You probably saved my life. I'm sorry I never knew to be grateful." The note is preserved in a small museum dedicated to the 79th Armored Division. In 2004, Dr. Harold Pemberton, a German military historian, published a study on Wehrmacht defensive effectiveness during D-Day. In his analysis of why Allied landing craft covering fire was more effective than German planners expected, he wrote, "Allied gun mounts demonstrated 400% improvement in reliability over previous amphibious operations. This rendered German defensive calculations obsolete and contributed significantly to beach penetration success." The innovation responsible remains one of the war's most tactically significant yet historically overlooked developments. A marginal note from Pemberton's research: the simplicity of the solution suggests that the problem was one of institutional thinking rather than technical impossibility. The Allies succeeded not because they had better technology, but because they were willing to listen to unconventional solutions from unexpected sources. Hitler's biggest secret wasn't his wonder weapons or his fortifications. It wasn't the V-2 rockets or the Atlantic Wall. His biggest secret was his own rigidity. The absolute certainty that German engineering was superior, that established methods were always correct, that innovation came only from credentialed experts in proper institutions. That rigidity extended to his enemies. German planners assumed Allied landing craft would have the same limitations they'd always had. Unreliable covering fire, high casualties on approach, predictable failures under combat stress. They didn't account for a tram engineer from Glasgow who didn't know enough about gun mounts to know that his solution was supposed to be impossible, and that blindness cost them the beaches, the war, and everything they thought their rigidity had secured. Sometimes the smallest mechanical innovation changes the course of history. A spring that absorbs vibration, a dampener that controls motion, 38 pounds of metal that let a gunner keep firing when it mattered most, and sometimes the greatest innovations come from the people nobody thought to ask. The ones without the degrees. The ones who fixed trams and learned that sometimes you have to let things move instead of holding them still. Thomas McKenzie never led troops into battle, never commanded a ship, never planned a campaign. But on June 6, 1944, his hands, the hands of a tram engineer who trusted his own observations over expert consensus, gave 2,400 men a chance to walk off a beach alive. That's not a bad legacy for someone who just wanted the tools to work properly.